All right. I think we're live. Pretty sure we're live. Let me just check. Yep, we are live. All right. Welcome everyone to another installment of the Daily Dose of LeetCode, where we go through all the questions on LeetCode, starting from the easiest all the way to the hardest. And we just have fun doing it. It's a great, fun way to learn. I've had a lot of fun doing it. I've gotten to become a little bit more involved with the community, so I think it's pretty neat to be able to do this with everyone. So I hope I get a good audience today. Really looking forward to it. So as of yesterday, we left off on 109 questions. And give me one quick moment. I'm just gonna put my table in sitting mode, I suppose. So it might make some noise. 1 second. All right. So one thing I'm really excited about today, kind of a minor, well, not really a minor thing, but I'm using my girlfriend's chair to sit on my desk. Her chair is way more ergonomic than mine, so it literally just changes my experience altogether when I'm thinking about just my work, how I approach my work. Truly getting an ergonomic chair is the way to go. If you haven't already, highly recommended. All right, cool. So like I said, we're at 109 questions today, and we're just gonna start off from where we left off yesterday. So I'm gonna go to algorithms here. Let's go easy. Let's go to acceptance and let's go for it. So we're going to go to page 2, making great progress. And let's see. All right, so our first question of the day is keep multiplying found values by 2. Let's go for it. Let's see what this question is going to be like. Okay, sweet. So what do we got? You're given an array of integers nums. You're also given an integer original, which is the first number that needs to be searched in for nums. You then do the following steps. If original is found in nums, multiply by 2. Set original equals 2 times original. Otherwise, stop the process. Repeat this process with the new number as long as you keep finding the number. Return the final value of original. Okay, are all these numbers distinct? That's one thing that would be nice to do. Give me a second. I'm just going to have a sip of water here. It's like a couple different things I'm thinking here. We have like 5, 3, 6, 1, 2, and we're looking for 3, right? So we find 3, we double that, and now this becomes 6. Now I guess we go through here and make this 12. Now we're looking for 12. We make this 24. Is that not how it is? Oh, and 24 is not. 3 is multiplied by 2 to obtain 6, but are we not changing? Okay, I guess we're not changing the value here. Okay, so it's 3. We find a 3, multiply by 2, we got a 6. Find a 6, multiply by 2, we got a 12. We find a 12, multiply by 2, we got a 24. But 24 is now not in this list. I think what we can do, if you think about it, anytime we want to find a new number, one thing that we can do is just search this array linearly for that new number every single time. But we can actually optimize it and put all of these inside of a hash set. I think that's something that we can do. Now, it would be nice if all these numbers were distinct. I don't think it says. Oh, the first number that needs to be searched for in nums. Okay, I guess maybe we don't even need to really, we can just count distinct values. Let me see, we have 279, 536, 12. So imagine we had, I want to think about this real quick. It'd be nice if, could we also just put this inside of a set though? Imagine I have a set, right, of 5, 12, 6, 1, and 12. Or 5, 3, 6. So in my set, I say while set.has original, then original equals set.get original times 2. Right, so original is 3, and now original equals set.get original times 2, which is 6. We look for 6. Okay, I think we can do this, I think that's one thing we can try, right? So let me try to do this. We can say const set equals new set of nums, and while set.has original equals set.get original times 2, and then return original. So let's sort of do it this way. Original is 3, output's 24. 3 is inside, so we do set.get original. 3 times 2 is 6. 6 is inside, so 6 times 2 is 12. 12 is inside, 12 times 2 is 24. 24. Now 24 is not in there, we just return 24. Okay. 279. 4 is not in there, so we return original. I believe we can do this. Now let's think about, I guess duplicates still matter, because even if we have duplicates, we at least have a single instance of the number, right? Original equals set.get original times 2. Well, set.has original. Set, is it not set.get? Let's see, mdn set. I'm trying to remind myself of the method. Maybe I'm just doing something. Oh, can we not? Wait a second. Do we even need to do this? We don't need to do this, right? We can actually just set original times or equals to. We don't need to get the original. We just know it's already equal to that. 24 and 4, 24 and 4. 94.76. Okay, let me remind myself the time complexity of creating an unordered set. So an unordered set, so I recently learned about ordered sets and unordered sets. That's just one thing I never really thought about. But if you think about an ordered set, it takes time to actually keep that ordered, right? So to be able to look up something in an ordered set is actually log of n, if we're considering that it's going to use some sort of tree-like structure. Whereas for an unordered set, we don't really care about the order, so we can just use a hash table. If I want to create a hash table, I'm going to need to at least go through everything in nums once. So let's say this is O of n, and this is, let's say in worst case, it has every single double. This might just end up also being O of n. So I'm comfortable saying this is an O of n, right? O of n time complexity, and the space complexity will just be equal to, let's say u, where u is the unique numbers in set. It could also be n in the worst case, where every single number is unique, sort of like here, right? We all have all unique numbers. So I'm pretty happy about this. Let's look at the discussion. Boolean array versus set or a hash. Hash the given array and keep finding, also O2. Complexity time of O of n. Constant, we create a hash, I++. Set versus sorting. All right, here we're looking at unordered set and set. Okay, cool. So I'm pretty happy with this. Let's move on to the next one. Let me remove some of these tabs here. Okay, baseball game. Let's see what we have here. Ooh, okay, this might be a question that's not of great value, but we're gonna go through with it anyway. So you are keeping score for a baseball game with strange rules. The game consists of several rounds where the scores of past rounds may affect future rounds' scores. At the beginning of the game, you start with an empty record. You are given a list of strings, operations, where ops of I is the ith operation you must apply to the record and is one of the following. Let me just check something real quick just to make sure we're still okay. An integer x, record a new score of x, plus record a new score that is the sum of the previous two scores. D, record a new score. Okay, this looks wild. So we add 5. So if we just get a number, at 5 we add 2. C, invalidate the previous score. Okay, add 5 to the record. Add 2 to the record. Record is now 5-2. Invalidate and remove the previous score. D, add 2 times 5 to the record. We invalidate the previous one. Oh, is D just, okay, double, okay. And then here, invalidate, add, record a new score that is the sum of the previous two scores. So I think what we can do really, if we just take this, imagine we have a stack, right? We see a 5, we add 5, then we see a -2, then we see a 4, then we see a C, which is to invalidate. So here we can effectively pop. Now we see a D, that is the double the previous score. So 2 times -2 is -4. Okay, and then we see a 9. We see a plus. Previous 2 scores, 9 plus -4 is 5. And then we see another, which is 14. And we have 20, oh, output 27. How do we get, oh, wait. 5 plus 2 plus 5 plus 14. Oh, do we have to just add and then, oh, return the sum of all the scores on the record. The test cases are generated so that the answer fits in a 32-bit integer. So I guess during the time that we're building this array up, we can also be modifying or like getting the sum, almost like a running sum, right? So let's say let sum equals 0. And let's see. So if we have a number, sum plus or equals number, right? If we have a C, then do we just do we do the -4? C invalidates the previous one. 5 and 2, 5 plus 2 is 7. We have a C, so we do what, -2? Then we have a D, that's 15. No, it's 10. Okay, that's 15. And then plus, would that just be 5 plus 10 plus 15 equals 30? So I guess whenever we have the C, right, if we have a C, we invalidate the previous score, removing. So I think from here we can just remove the previous score. Sum minus equals previous score. Then we have a D, so we can just double D, sum plus or equals previous score times 2. If we have a plus, sum plus or equals, and this will be the previous 2 score. Previous plus previous previous. And I don't mean here to say previous minus previous. I'm just saying like double the previous. So do I even need a stack for this really? 5 plus 2. I can do a plus 4. But how would I now keep track? Oh, I always have, yeah, 5 plus 2. 5, 2, 4. I see a C. I subtract the previous one. But if I see like a D and a C, so I just subtract the previous number, maybe I should just have a stack that I use to hold numbers. So I see a 5, enter a 5, I see a -2, I see a 4, I see a C now, so do minus the previous one, I see a D. I think that's what I want to do. So I almost want to have like my const stack be equal to an empty array. Now for const, let's see, operation of ops. Let's come up with a few different test cases. Like the last thing I know could be a number, and I think that'll make it easier. We don't have to like decide first if it's a number or anything. So we can say if operation equals to C, we can do, actually I think a switch statement for this might be nice. We can switch on the operation, right? We can have a case for C. I'll just break for now. We can have a case for D, and break for now. We can have a case for plus, break for now. Else default will be the number, right? So const number equals parse int operation. And here we'll pass in 10 for our radix. I'll just break for now, but we can continue here. So if we have a C, and let's sort of do this the whole way, right? So if we have a number, we can add it to our stack. Here we can say stack.push number. If I have a C, I can say const previous equals stack.pop. And then we can say, let's say here, let sum equals 0, sum minus equals previous, assuming that previous is always, I think here it said that will be valid, always be at least one previous score on the record. Okay, cons previous, and then D is going to be which one? We double the previous one. Cons previous equals stack at stack dot length minus 1, sum plus or equals previous times 2. If we have a plus, we can say sum plus or equals stack at stack dot length minus 1 plus stack at stack dot length minus 2. This is one way that we can approach it. Break, 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 and then we end up with, I think we can be doing the sum at the same time, right? Over here we should just be able to return sum. So let's like debug this. Let's go through it. Let's pick like one of these nice long ones here. Right, so we have this up here. Let's say this is my stack. I'll have put my stack up here and I'll put my sum here. We're gonna start at 0. Okay, first thing I get to, it's not a C, it's not a D, it's not a plus, so it must be a number. So I parse it and I push the number. I have 5. Parse it, I parse the number. I have a 4, parse it, I push the number. Now I have a C. So if it's C, I pop, right? Oh, we're not also, I should be doing, every time I get a number, I should also do sum plus or equal number. Right, so I have, let me actually start over here. I have 5, sum is 5. Push -2, sum is 3. Push 4, sum is 7. I have a C, so I pop 4 and I subtract 4 to get back to 3. I have D. I add these two, 5 plus -2 is 3. I can push a 3. Or actually, I don't think I need a 3. Oh, this is where I think we always need to add. Yeah, anytime we add one of these, let's see, sum. I think I should always be, let me think about this. I think what we can do, maybe the default, do I always want to take, if it's not any of these, nothing will happen, but I always want to record the new one. The new one will always be a number at the end. So that's always what I should push. If I have C, D, or plus, I'll always have a valid number to work on. Else I should transform it to be a number first. Interesting. Break, break, break. Should we always get to that one at the end? I think I'm making this more complicated than it needs to be. 5, -2, then 4. I'm gonna start this over, but I think again I'm making this more complicated. This is a 5 because it's a number. Then I do a -2, so this will be a 3. Then I see a 4. I put the 4. This is a 7. I see a C, so now I pop it and I also subtract it. Right? Am I even doing that here? Yeah, sum minus equals previous. Okay, cool. So I subtract it. Now I see a D. When I see a D, I need to record a new number. Yeah. I need to actually get const previous equals stack sum plus or equals previous times 2. And then inside of here, I should say stack dot push sum. So get D is 5, or 2 times -2 is 4. I'll add the 4 here, and then I'll also add it here. Now I see a 9, so I put a 9. 9 plus 7 is 16. I see a plus. I do 9 plus 4, which is 13. So this becomes what, 29? But again, we should add this here. Hey, Rafael. I recently started taking my computer science degree quite seriously and started watching content creators in the field. Just wanted to mention I really appreciate these streams. That's so nice to hear, Ryan. I really do appreciate you coming along. I think you're doing the right thing. It's good that you're still in your degree and doing this. I graduated university in 2017, so it's been about 5 years now, and I really wish I was doing something like this during that time. So I could only commend you for doing exactly what you're doing. And I definitely encourage you to stick around and also continue watching other streams, as I feel like there's a lot of value nowadays and a lot of things you can find on YouTube. So yeah, thanks again for joining. Really appreciate it. Hope to see you around more often. So we have this one, and now we do 29 plus 9, which is that going to be, so it's still 27. So I feel like there's a simple thing I'm missing here, only because we've been sort of going at this question a while, and because I typically don't like coming up with excuses. I know we're probably really close here. It might be, you know what? Let me try something though. Stack dot push sum. There's a lot of there's a lot of, yeah, stack dot push sum, stack dot pop, and then we push it. No, I don't need, yeah, if I do previous, I pop it, right? Sum plus or equals, stack dot push sum plus or equals. We might just be able to return sum here, but I feel like I made this one a little more complicated than it needs to be. Const previous. Why doesn't it like this one? Are these not scoped? Oh, is this not? Wow. Maybe here I can say like popped. Or maybe here I just say stack.pop. Just to make that easier. And then const previous is this one. Okay, let's try this. Did I put sum equals? Oh. I think I made, yeah. Probably a little more complicated here. 35 and 30. Let me spend a couple more minutes on it. Oh, because we're so close. Const operation, switch operation. If it's a number, we parse the number, we add it to the sum, and we push the number. It's another one, so we get a 7. We push 7 onto the stack. We have a C. Oh, so we don't invalidate the previous score, removing it from the record. Oh, so we're not actually subtracting the sum. We're only doing stack.pop. But maybe because I added it, I feel like if I'm not going to consider it anyway in the final score, 5 plus 2, this is a 5 plus 10. 5, add 2 to the record. Validate the previous one. Record is now 5. It should be fine, right? Because I'll get to the 5. Sum minus equals stack.pop. Hello. Hey, what's up, Sam? How you doing? Good to see you around. Dealing with a question here that's just like, look at the like to dislike here. I know I'm very close, and I might just skip over it because we've been spending a lot of time on it, and we can probably benefit from visiting other high quality questions. I think we'll do that for the sake of the stream. So let me back out of this one. Let me close this one out here, and let's go to middle of the linked list, which I do think this is a good question to look at. So given the head of a singly linked list, return the middle node of the linked list. If there are 2 middle nodes, return the second middle node. So this is like a very classic question. This does have a very nice like to dislike ratio, very high quality question. And it's essentially the midpoint, right? So if we're given a odd list, the midpoint is just like length divided by 2. And if we're given an even list, it's going to be length divided, right? Because this is 1, 2, 3, 4, 5, 6. It's going to be, I guess it'll also just be 0, 1, 2, 3, 4, 5. Yeah, I guess we can count the whole length, divide that by 2, and we'll also just get the one that's there. But if we think about it, like if we're gonna be dividing by 2 at the end to get the midpoint, it almost seems that it's almost like the inverse, right? Like to get to the midpoint, we can iterate twice Like we can iterate over every other one while we have another pointer that goes to the end. And I know that was probably like a terrible explanation. So let's open up Excalidraw here. So let's just imagine, right? We have 1, 2, 3, 4, 5. All these are connected. You're already past 100 subs. Sheesh. I hope one day to be 5% like you. Oh, MMD, thanks. I really appreciate that. But let me tell you, like, you will absolutely be way more than what I am. I mean, it's taking me so long to be able to get to here. It's honestly just about consistency. And if you follow my streams and just like keep up with what I'm doing, then I think you'll be in the right place. And there's like plenty of other resources too to like check out online to be able to, yeah, and that's good. It's fine that you're a noob, and even if you consider yourself that, like, let me sort of show you. I don't know if this is your first time here, but I have to at least reference my YouTube because it's gonna help you here. So if you go on my YouTube, I have a playlist called LeetCode Live. And with LeetCode Live, you can start at this first video here. So it's called LeetCode Accountability Stream Number 1. Start here. And just like pause that, right? So if you look through this, this starts you off at the 0th question on LeetCode. Like I literally started from question 0. And oh, nice. I did your before example in Python just now. Nice. That's awesome. Yeah, I don't know how much you've been following, but yeah, if you follow along all these previous ones, I have chapters of all the questions we do, and then I also link to all the questions, so you can sort of like hear me, you can hear me talk about the different questions, how I approach the problems, so on and so forth. So, but it's super cool to have you around, so thanks a lot for joining. Let's get back to this one over here. So imagine we have 1, 2, 3, 4, 5. I don't know how to explain the relation, but like, if I want to get the midpoint of this, I can just take the length. Imagine this was an array, right? I can take the length and divide it by 2, and that will give me this guy right here. All right, because the length would be 1, 2, 3, 4, 5. 5 divided by 2 is 2.5. We truncate that to 2, and we get our midpoint here. I just joined your Discord. I'm not a Discord fan, but I have to do it. I also thought I wasn't a Discord fan either until I made the Discord. And then I made the Discord, and I started meeting a lot of people, and it's been a lot of fun just like being a part of that and seeing it grow. So thanks a lot for joining. I know Sam, I feel like I always call out Sam, but Sam Wong earlier on in the chat, he's actually one of the moderators on the stream, and it's just cool to have support from him on the stream here. A moderator on on the Discord server. I don't know if I said the stream, but yeah, it's cool to have people from the Discord here. That's awesome. Thanks for joining, man. So it's like you divide the length to get the midpoint here. But if you think about dividing, it's almost like there's something else you can do by 2's. Like you divide by 2, you can do some other operation by 2 to get the midpoint. And I know, again, that sounds really bad. Just makes like no sense. So what's like a nice way? What if we have like this triangle here and then this square? Like imagine this triangle, right? Like went like twice, 1, 2. Every time that moved 2, this thing went up 1. This thing moves 2, and then this thing moves up 1. Right? And now like we can't move 2. We can move once more here, but we can't move one more time from null. So we can just sort of say like, okay, while this thing's next is not null, or itself is not null, then we can do it. Because if the next one's not null, then we can go here, and then we can also go here to get null. Or if this is null, we can't do anything. And that's really what it is. That's all you have to do. I don't know if I explained it too well, but I hope it's kind of intuitive. I should find a better way of explaining that. But you move this guy twice, you move this one once, move this guy twice, you move this one once, and now you can't move this one anymore, and you're in the middle. And now let's do it for the other one, right? We have 1, 2, 3, 4, 5, 6. So let me just like copy all this, put it over here. 1, 2, 3, 4, 5, 6. All right, so imagine you have the same picture here. Move this one twice, move this one once, move this one twice, move this one once, move this one twice, move this one once, And now you're at the 4, right? Which I think is what, yeah, that's what they want us to return, right? So like here, we were able to move it twice, right? Because check it out. We like twice, once, twice, once, twice, right? We can go to 6 and we can still go one more and that'll just leave us at null. But that's okay because the next time we check this, it's going to be null. So we're going to stop there. So we don't have to like do anything more with this one. So if we think about the code, right, we can say let current, or maybe we can say let middle equals head, let runner equals head, and we can say while runner, right, while runner or runner.next. Or maybe we can say, well, let's just try this out and see what it does. I'll get to that in a second. But we're going to do the same thing we just did, right? We'll do middle equals middle.next, runner equals runner.next.next. So let's come back to this example here. So we say, okay, imagine runner is the diamond. So while runner or runner.next, runner's true, runner.next is true. So we go twice. And then we also move this up. While runner or runner.next, yep, that's fine. So 2 up here. While runner or runner.next, yep. So 2 up, go here, that's fine. Let's go over here. Runner or runner.next, yep. So move 2, 1. Runner or runner.next, true. Move 2, 1. While runner or runner.next. So I think it should be while runner and runner.next. Or maybe do we even need, because we can be here, we do 2. Yeah, let's do while runner and runner.next. And then we can just return middle. Three, 4, 5. I think generally, like as far as time and space complexity, the percentage will be like a huge indicator as to like whether or not you got the answer right. But some languages just have they're just faster. Like if you do questions in C++, I would imagine that a similar, like a question done the same way in JavaScript and C++, the C++ one will probably run faster. And I think those times are probably governed by the machines that these solutions are being executed on. I could only imagine that like LeetCode probably has some virtual machines that this code is compiled on. You can imagine like anytime I press submit, there's like a request that's made to some server. It runs the code for us and responds back with some result. That could probably be a way of designing this. So the percentage here I think is largely dependent on that. I think what you probably want to focus more on is like time complexity. Like if you have a quadratic time complexity solution, then you should try and see if there's a way to come up with like a O of n, like a linear time solution. I think there's something called the best conceivable runtime. That's something that could be useful during an interview. I have read in some places, for example, you might be, obviously if you ask the interviewer, it's better if you come up with it on your own, but you could ask them what's the best conceivable runtime, and maybe they'll say, well, there is an O of n solution. So maybe based on that, you can try and figure out the O of n solution. Or in your case, you'll tell them, hey, I have an O of squared solution. Is there like a possibility to do O of n or log of n? Sort of like just have a conversation with the interviewer. I need to get good books. There's one good book that we were like starting to read. This has really nothing to do with LeetCode, but designing data intensive applications. If anyone's doing like system design, we were starting to read this book on our Discord. We used to have like a book club, and I used to I did it once only that I like sort of hosted a book club meeting on a Saturday where I talked with some of the users about the first chapter. But this is a fantastic book for anyone looking to get into system design. Highly recommended. So we got to do it again. Oh, which one? No, I don't think we have to do anything again. Cool. So that's the middle of the linked list. Count prefixes of a given string. Let me just remove these and come up here. Okay, so you're given a string array words and a string s, where words I and s comprise only of lowercase English letters. Return the number of strings and words that are a prefix of s. Okay, I'm gonna get some more water. Just 1 second. Oh, yeah, it would be cool to do it again. Book club would be awesome to do again. I just have to. The thing is, it'd be cool if other people hosted it, because in the beginning, when the Discord was like a lot smaller, I was hosting it. But you know, sometimes I just had like other things I wanted to do on a Saturday. You can imagine at the end of like a hectic work week, you might just want to like enjoy your Saturday morning. So it'd be cool if like other people are reading and they also volunteer to like host book club meetings on Saturdays. That could be like a way to scale it. But awesome. Let's get to this next one here. So you're given a string s of array words, a string array words, and a string s where words I and s comprise only of lowercase English letters. Number of strings and words that are a prefix of s. So A, B, C, A, B, B, C, and A, B, C. So B, okay, so A, yep, A, B, and A, B, C. Okay. Let's think about this. So A and A, S's, A and A are both prefixes. Only of lowercase English letters. So there's definitely like a good way of solving this. I'm wondering if I could come up with like what's the words at length is 1,000, words I dot length, this is less than or equal to 10. So the principles of combinatorics. Yeah, I'm not too familiar with combinatorics. I like took a discrete math class in university for like a week, and then I was like, I'm not doing this. And I stopped taking it. That was like when I was like, oh, I want to do. So I got a degree in audio engineering, and I'm like, oh, I want to do an audio engineering and a software engineering degree. So let me like try to get a double major, and then they had me do discrete math for like a week, and it was just, I was like, no, I'll just learn coding online. Okay, substring that occurs at the beginning of the string. A substring is a continuous sequence of characters within a string. So there's an obvious solution here, like a brute force solution, right? But let's see, B, C, A, B, C. I almost feel like we could construct, and I don't think that an easy question would have us working on data structures like tries. But what if, I mean, right? Like if we create a try of S and I try to look for BC, that I wouldn't find anything, right? I wouldn't find B, I wouldn't find C. I would find AB, I wouldn't find BC, because I'd fail to find like the first thing. So this should be, I think we can do O of N times W, or M by N, where M is the amount of words in here and N is the length of each word to be able to look up in our try. But should we even create this? Is there an easier way to do this instead of having to like create a try? If I have to create a try, I might just skip it because JavaScript doesn't provide, I don't even know of any language that provides an easy like try implementation out of the box. Never seen that before. That'd be cool though. Only of lowercase English letters. The fact that that's bolded is very interesting to me. A, B, C. Oh, and they have to come in that order, right? They have to come inside of that order. So could we actually use words.length, words of I, S, dot length is less than or equal to 10. I mean, could we create an array? of size 26. You can create nodes with a list of 26 length. Oh, there you go. Yeah, I'm thinking about doing that. You can create nodes with a list of 26 length. Are you just talking about like using something like counting sort? Like what if I just have like a single array that just has like A, B, C, where I just know this is the order, right? And then when I find A, maybe here I say, okay, like, well, would that be fine? If I get to BC, I would start here, but then I miss out on this one. So that wouldn't work. Or just maybe if I'm like, no, I guess that would be, yeah, if I'm looking through this every single time. N, I look through here, M by N. Well, could it actually just A, B, C? A, both of the strings are a prefix of S. Oh, here we go. Yeah, you create nodes with a list of 26 lays. Then that's all the letters. Ye. Right, that's all the letters, but I'm just wondering, I mean, their array in and of itself will keep like the ordering, right? So if I get to, I'm just trying to like map in my head. All right, MMD. Yeah, thanks so much for joining. Hope to see you around tomorrow. Like normally in the morning, I schedule the live stream, so you'll be able to see like way ahead of time when I'm planning on having it. So hopefully, yeah, hope to see you tomorrow. Thanks for joining. ABC. If I have ABC for 0, 1, 2, I get to the B, that's a 1. But how would I know at that moment that it's not a prefix? Like, is it because I just have to start at 0 every time? I have to necessarily start in the beginning? ABC. Putting all the words in the try to get the optimal solution. Yeah, I was thinking about that too. Like that was my first thing, considering a try. But I also feel like a try for an easy question seems odd. Let's look at related topics like, okay, array and string. Right? I mean that could be optimal, and that's probably like an easier way of doing it. But it just seems a little bit weird. Can't find it. If I get to the end, AB, that's fine. BC and then ABC, array and a string. It's not. Oh, hey, Sugoi. How you doing? Good to have you. Give me a second. Let me put some light on here. Okay. Oh, wait. I think I showed my email for like 1 quick second there. You guys are going to see emails. It's not clear to me how I can use that counting sort to be able to do that. Try isn't a topic because the constraints are too low. Oh, probably. That makes sense. S of A, ABC, AB, BC, ABC. Strings and words which are a prefix of S equals ABC are A, AB, and ABC. I mean, I guess like anytime I start, what if I just kept like the root? Like for any one of these, I know it's always gonna have to start at whatever this is, right? So we can sort of say like const, let me see, const alphabet equals new array of 26 dot fill 0, right? Let me get this part done with at least. For const c of s, const index equals c dot car code at 0 minus 97. I'm not even sure if this is, I don't think I have to keep the frequency, but I suppose we could do that. Like here, my start index will just be s of 0, right? Like I need to at least, like the first index of my word needs to at least match s of 0 or alphabet of 0. Wait 1 second. No, the start index has to be s at 0 dot car code at 0 minus 97. That'll be my start index inside of alphabet. So I can just start going through this, say, okay, A, this matches that. Okay, that's cool. And then maybe I can start sort of like a loop on both of these and just go from there. So let prefixes equals to 0 for const word of word if and wait, I don't need to declare my start index out here. I need to only figure out if word of 0 equals to s of 0, then do something, right? Actually, this is the only case I ever need to do something. And then from here, I can essentially just, let's see. Let's create like a new function, something like is prefix word. And then we can do for let I equals 0, I less than word dot length, I plus plus. If word of I is not equal to s of I, return false, return true. Inside of here, if word of 0 equals s of 0 and is prefix of word, and we can say prefixes plus plus, return prefixes. Let me see something here real quick though. So if word 0, like a is equal to a, right, and is prefix, so we pass in the current word a. For let I equals 0, I less than word dot length, if word of I not equal to s of I, and then this just goes out of bounds and that returns true, right? So this is not equal, this is not equal, this is equal. We go through the whole string. Okay, awesome. Here, this is always the same, so we never get to false, so we return true. So let's try this out. Const, oh, I think this is for const word of words. Oh, wait. What does it not like? Did I make this? Oh, did I delete prefixes? Three and three. Took a little bit long to run, but let's see. Oof. That's gotta be one of the worst. I mean, I've had like 5% before, but not in any of the easy questions like this. 61, okay, a little bit better. I think probably going with the try solution is the way to do it. At least easy, I mean, at the easy level, 18.8. Let's see what discussions have to say. If I see try, I'm just gonna back out. Because I'm gonna back out because I wanna try it myself. Starts, okay, starts with count if. For each word, check if word starts with string. Okay, well, we can do that. They're essentially just using starts with, which we definitely could do. I just don't know. It's one of those things where it's like use the language API or just sort of come up with your own way like this. What is it they want to see in an interview? Did I even use this at all? I didn't use any of that, right? Const alphabet, I didn't use any of this. So that's probably gonna Yeah, that's definitely gonna add some time there. 53.85. And then I think I'm because then here, I mean, if it's not immediately equal, this would still be like, is it even worth it to do this check here? Even if I enter this function here, it would still break out immediately. It's just going to be a single operation. I'm not sure how much optimization we're getting out of doing this. This seems just like a unnecessary optimization I'm doing here. Like perhaps I can just do if is prefix word, prefix is plus plus. But then at that moment, we might as well just do, let me see, we can probably just like reduce this, but that's just getting fancy for no reason. Let's see, 3 and 2, 22.51. I believe, let me see, does MDN string starts with, do they have starts with here? Oh, okay, cool. So that actually does work. So could we, I think we could, with starts with, yeah, we can make this very simple. We can return words.reduce acval if, let's see, this is the current value. So if s dot starts with the current value, return act plus 1, return act plus 0, give this an initial value of 0. Let me see what this does. 3 and 2, 3 and 2. Okay, yeah, so two different ways of doing it here. One that's a little more, I suppose it's imperative, and here we're using, you know, just like a method that comes with or on the string prototype. Pretty cool. I haven't actually used starts with before, so that's cool to know that it actually exists. Seems like a good method to have. So all right, so number of recent calls. Why do I vaguely remember this as being, oof. I'm not honestly not even gonna bother with this question. Let's save this for another time. That's just a terrible like to dislike ratio. Delete node in a linked list. Ooh, okay, I know this one. This one, like, the only reason I hate this question is because, and it seems like a lot of people hate this question, is I guarantee you every person that stumbles upon this question is doing the cracking the coding interview style solution. And that's exactly what I'm going to do here, only because I don't think this question deserves any more time than we need to give it. So literally what they do is they set the node's value to be node.next.val, node.next equals to node.next.next. Right, so the given node is 1. We make the next one 9. Node.val is node.next.val, and then node.next is node.next.next. I don't think it wants it yet. Don't return anything. So this question's crazy. I actually remember, I think Sam, we were on a call once looking at this question, and I know you had your own thoughts about like garbage collection and stuff. If I remember correctly, that was definitely a thing. So yeah, I think this question doesn't need any more time. I think it's just one of those things that if you get this in an interview question, that's awesome. Well, it can be awesome or scary. Awesome because maybe it's just this easy, but maybe scary because they are maybe trying to trick you and see how deeply you think about it. Perhaps there's way more to this than just meets the eye, but I suppose it's good to maybe reinforce linked lists for you. But like I said, that's the only time we'll give it. So 2 out of 3. Given 3 integer arrays, nums1, nums2, and nums3, return a distinct array containing all the values that are present in at least 2 out of the 3 arrays. You may return the values in any order. 1, 1, 3, 2, 2 and 3, and 3. The values that are present in at least 2 arrays are 3, 2, 2 in nums1 and nums2. Okay. Now do each one of these have distinct, okay, oh no, wait, given 3 integer arrays, return a distinct array containing all the values that are present in at least 2 out of the 3 arrays. So let's think about this. Imagine we just want to return a set, right? Let's see. If I create a set of 1, 3, 2 for the first one, I get to the next one, I see a 2 and 3 is there, so I don't do anything. And then I see a 3. 3 is in all 3 arrays. 2, 1. I can also maybe just keep a frequency of each one of these. Let's say 1 is going to be 2 for that first one. Give me 1 second. I'm going to put the AC in my home on. It's very hot right now. I live in South Florida. So you gotta keep up with the AC. If you're not putting your AC on, then you're just gonna go crazy. So I'm gonna put my AC on, get that nice airflow. Hopefully it's not making too much noise. This mic is very sensitive, so 1 is 2, 3 would be 1, and 2 would be 1. And then the next time, I guess like I only add when I get to the next one, right? So now I have another 2, and then I have another 3, and then I get to a 3. Values that are present in at least 2 arrays, 1, 1. Oh, but see the 1 here, yeah, that's not actually present in the other one. No value is present in at least 2 arrays. nums1, nums2, and nums3 return distinct array containing all the values that are present in at least 2 out of the 3 arrays. You may return the values in any order. Interesting. 2 out of the 3 arrays, you may return the values in any order. What if we just had like multiple, I feel like it could be something with keeping like a frequency of these digits at every step and somehow taking the difference, like only keep what's in this one by the time I get to the next one. So let's say I have a 1, a 2, and a 3. I can create my, okay, so let's say I have the previous, this is like my previous one, and then I create a new one in the first one. So I say, okay, I have 1, I have 2 1s, I have 1, or 3, I have 1, and 2, I have 1. And then for my next one, I say, okay, there's a 2 here. Was there a 2 in the previous one? Yeah. Okay, so that means now there's 2 2s. Was there a 3 in the previous one? Yeah, so now there's 3 2s. Okay, here. Oh, but now I only have 3. So I say, is there a 3 in the previous one? Yeah. So now there's 3 3s. But then there was also 2 2s. I can't just like remove, I just can't remove that, right? Maybe I can build it and then keep, why would I not, like why would I throw away the 1 here, but then keep the 2 here? There's a 3 in the previous one. There's a 2. What if I also just kept track of the array that they're in? Like I have a 1 and 0, I have a 3 and 0, and I have a 2 and 0. Here I have a 2 and 0 and 1. I have a 3 and 0 and 1, and that's it. And then 2, I have 2. So I could also do this, and then maybe I can loop through all these values and just return the ones that have a position in either one of these. Now, how do I guarantee I only add it once? I don't want to have to add these every single time. I think we can do that. And I could also say, like, have I seen... Oh, and I can always check. Okay, I think I know what I can do here. I think I know what we can do here. So we're gonna loop through all our different numbers. At least that's what I'm thinking of doing to start off. Obj, obj, obj. Okay, so we have, let's say, count or const. Wow, const indices. I'm not really sure of like a better name here. I can loop through, let's see, for const n of nums1. Let's see, if it's not inside, and I guess, oh no, will this only ever happen once? No. I'll say if indices of n is equal to undefined, then here I can say indices of n is equal to an empty array. Well, this is only the first time. I think the first time I can just set this equal to 0, right? Because I'll say 1 is not there, make it 0. 1 is there, don't do anything. 3 and 2, set them to 0. Now for the next times, like for const n of nums1, for const n of nums2, this will be a little different. So if indices of n is equal to undefined, here indices of n can equal to 1. But now we also want to look at the previous one. Like if indices of n, let's see, indices of n is going to be an array. So I actually want the thing that's at the end. Yeah, this is going to be a little bit weird. Const n indices equals indices of n if n indices at n indices, oh man, at n indices dot length minus 1 is equal to 1, is not equal to 1, then we can push 1. So let me explain what I'm doing here. Push 1. So what I'm trying to do here is like, okay, let's say the first time we go through this, right? I'm going to draw an object literal here as we go along. This represents this first loop right here. So we're going through 1, 1, 3, 2. Like indices of 1 is undefined, right? So I make it 0. And I say here 0. Then I go to 1. It's not undefined, so I don't do anything. I go to 3. It's undefined. I set it equal to 0. I go to 2. It's undefined. I set it equal to 0. Okay. Now we have this, and we start in the next one. Now it's 2 and 3 that we have. So we say if indices of 2 is undefined, which is not, I get n indices, which is this array right here. If n indices at indices.length minus 1, which is the previous one, if that's not equal to 1, it means we haven't yet added this, right? Else, if we had already found it once, we would have already had 1 here. So we can just add it there. And then I think I could do the same thing again. And now as I'm doing this, I realize I might not even need to worry about the index it came in, maybe. But we'll figure that out in a moment. If n indices dot length minus 1 not equal to, so we'll make this 2. Length minus 1 not equal to 2, we can push 2. So I should now just be able to loop through all of these and return however many. Output 2, 3, 1. Okay. So let's say const 2 out of 3. Const results is an empty array for const key value. For const key value of object.entries of indices. Here, let's see, the value of the key value here will just be an array. So if value.length is greater than or equal to 2, then result.push key, return result. Now, does this need to be in any specific order? In any order. Object.entries. Oh, I used the wrong thing. Instead of it should be indices. 2 and 3, okay. We're gonna try something else though in a moment. This works. 2, 3, 2, 3, 1, and 3, 4. Whoa. Okay. That's like wildly different than what we got here. Wait, this is 4, 3, 3, and 5. I might not be considering. There's definitely like an edge case here, right? 1, 2, 2. So it's 0 and 0. 4, 3, 3. And then 5. So how do we not end up with, what's the console.log value? Let me get my test case here. Zero, 0, 1, 2, and 1, 2. How do we even get? Oh, wait a second. Am I doing? Oh man, I did nums2 twice. Okay, there you go. So this looks a little better. Let's get all our test cases back. 2, 3, 2, 3, 1, 2, 3, 2, 3, 1, empty, empty. Let's try it out. This works. Okay, it worked. I'm not thrilled about the percentage here, but I think we don't even maybe need to take, I don't even think we need to necessarily have like an array here. What if I just assign like a point value to each one of these? In the beginning, they could only ever be 1 because they're just part of nums1. So if it's undefined, we can just say indices of n is equal to 1. Here, if it's undefined, no, that's not going to work. Because how many can it be? 2, 3, that's 5. So if it's part of all of them, let's say, it would be 6. I can't, 1 plus 2 is 3, 2 plus 3 is 5, 1 plus 3 is 4. Okay, if it was only part of 2 and 3, well, maybe it could work. But you know what? We're having fun here, so let's just try this out. I'll set this equal to 2. Indices of n equals undefined. Indices of n is equal to 2. So const n indices if n indices at length minus 1 is not equal to 1. So if I wouldn't have seen it before, yeah, this is weird. Assigning a point value. I would have only not seen it if it's not equal to, if it's the first time I've seen it, then I add it there. Else if it's the second time I've seen it, then do we just indices of 2? Wait a second. What if I just do like, I don't even know if I'd call this greedy, but I'm gonna try something crazy here. Indices of n plus or equals 2, and then here let's do 3. This logic might be entirely wrong, but we're gonna give it a shot. Equals 3, and like, could it be the case that only if their key value 1 plus 2 plus 3 is 6, you can't get 6 any, oh, but they need to be in at least 2. Oh, that just makes for some weird logic, because you can have multiple options here. You can have 1 plus 2 or 1 plus 3 or 2 plus 3, 3, 4, or 5. So if it's greater than or equal to, if it's greater than or equal to 3. 1 plus 2, 1 plus 3, or 2 plus 3. That seems crazy, but let's try it out. If that works. 2, 3, 1, 2, 3. 3, 4, 5. Wait. 3. Oh. Yeah, I don't want to oh no, if indices of n equals undefined, we make it a 3, but if we find another one, yeah, no, this is gonna be crazy, because then no, this won't work. There's a better way of doing this, though. I promise you, there's a better way of doing this. There has to be. Wait, how far did I go here? Of indices, this should be nums 3. Empty. 51.65. Let's see discussions. Three count arrays. Wait a second though. That's sort of what I did, no? Probably gonna be like a one-liner. Element can appear in the same array more than once. Count elements independently. Alternatively, we can dedupe arrays first. Straightforward. 3.101. For const n, 0 n equals true. For const n, 1 of n equals true. For int I, result dot push back. Okay. Oh, so he just overrides the value. He loops through if is greater than 1, then push back I. Interesting. Cool. I'm having like a pretty fun time here right now, and I know we're over the hour, but I wanna maybe see if we can do a couple more here. Maximum depth and invert binary tree. Two nice ones that we can get to right before the end here. Classic question here, right? So let's draw this one out. This is like textbook algorithms 101, blind 75, LeetCode 150, all that good stuff. 3, 9, 20, 15, and 7. 3, 9, 20, 15, and 7. 20, 15, and 7. Okay, so how do we do this, right? Maximum depth of a binary tree. I think a root node has a depth of 0, right? That's something exactly. Yes, mean. It's meme question. This one, I don't know if you're talking about this one or the invert. Yeah, if you guys don't know about the invert binary tree, there's like this meme. Yeah, let me see. I just pulled up a random thing here. Google, 90% of our engineers use the software you wrote, homebrew, but you can't invert a binary tree on a whiteboard, so screw off. So that's your comedic relief for the stream. I don't know if that's what you were talking about, Sam, when you were referring to like a meme question, but yeah, this has been shared a lot. So let's go on with this here. All right, so in classic recursive fashion, to figure out the maximum depth of a tree, we figure out the maximum depth of its children, and then we add 1 to it, right? Because if we figure out the maximum depth of this one and this one, we also need to account for the one that we're currently on, so we add 1 more. So what happens? We go to the left, right? Then we go to the left again. The maximum depth of a null node is 0, so the left here is 0. The maximum of the right here is a null node also, so that's 0. So 0 plus 0 to account for left and right, plus the one we're currently on, so this is 1. Right? And now 1 becomes the left of 3. So I'll go in here and write left equals 1. Now we start going to the right, and then we go to the left. A null on the left, a null on the right. 0 plus 0 plus 1 is 1. That becomes 20's left. Right? So a left is a 1. We go right. Left and right are null. So that's 0. 0 plus 0 plus 1 is 1. That becomes 20's right. Right? Left 1, right 1. So 1 plus 1 plus itself is 2. right? So we return 2 now. We get up here, and we say 1 plus 2. It's going to be the maximum depth. So we take the maximum value of 1 or 2. We say we take 2, and we add 1 to it, so it's 3. And we have 3. And that's exactly the algorithm. So we figure out our base case. We know that if the root is equal to null, we return 0. Else, we get the depth of the one on the left, max depth of root dot left. We get the one on the right, that's max depth root dot right. And then we return the max of the left and the right one plus 1. And I'm just going to submit this. I'm not even going to run the code. And we'll get it right. Now, this question I've seen so often and so many times. It's honestly, I'm not saying it's worth memorizing. Like, you should be able to understand why this works. If you can at least go through this, manually like I did and draw it out and understand why it works, that's definitely step 0. But then at some point you'll probably just memorize it, and that's fine. I think it's fine for a question like this. So that's pretty much it. It's fun, and we can condense this, but I like readability, so I name my variables, make it very clear what I'm doing here. So I think that's all fun. Let's get to now the meme question here. Invert a binary tree. If you know how to swap two numbers, you can invert a binary tree. That's exactly what it is, right? We can use a post-order traversal to be able to go through our binary tree here and then revert nodes as we're going up. So let's do the same thing. 4271369, right? 4271369. 4, 2, 7. Let's do 1, 3, 1, 3, 6, 9. Here and here. Okay, cool. So imagine we're doing this, right? We do a post order traversal. So we start here. We go left. We go left. Go left, there's nothing. We come up. We go right, there's nothing. We come up. This is a leaf node, so we don't even need to do anything. Now we come up here. I think we only need to do something if at least one of the children is available, right? So now we come up here, we go right, same thing, left, right, nothing, come up, we come here. Now we can just reverse these roots, right? So we can say this now becomes 3, this becomes a 1. We're up here, now we go up here, do the same thing coming down here. Null and null. This has no children, go up, go right. Null and null. This has no children, go right, or go up to the parent. We can reverse these, 9 and 6. Then we come up here, we can reverse this, so 7 and 2. And then we come up here, and that's pretty much it. So I never actually did. I would always reverse even if it's a leaf node. But I think now that I'm looking at it, we don't need to do anything as long as we don't have, like, we need to have at least one child, right? Because we can have something like this, and I'm pretty sure that if this was like a 10, for example, they would want the 10 to instead become the left child and the right become null. So I think we do have to account for that. So let's try different base cases here. If root is equal to null, we can do if root is equal to null or not root dot left and not root dot right. We can just return, I suppose we can just return root here. Let's put this on a new line here, right? So this is the base case. If it's null, we just return, or if it's a leaf node, we just return. And then really here, what we can do is I'm just going to use some fancy JavaScript. I want to see if this actually works. So I should be able to do root.left. Actually, first I have to go all the way down, right? So let's do invert tree root.left. Invert tree root dot right, and then here we should be able to do root dot left root dot right is equal to root dot right root dot left, return root. So let's try this out. 4729631 looks good to me. 231 231 and then empty array. Let's run this. 98.74, that's really nice. I really like that time complexity. And this is a binary tree. Okay, so I was just, let me add these to my lists. I think this is really nice. So I'm saying it's a binary tree because we're gonna have to go through every single node in this tree. So this will just be O of n, right? Unless if it's like a heavily skewed tree, it's, you know, well, I guess even a heavily skewed tree, because it's not a binary search tree, it would still be O of n. And then as long as it's height balanced, we would just have to keep track of O of h of internal stack space for the height. For the, this is maximum depth of the binary tree, same thing. We'll have to visit all the nodes here, so O of n. And then the stack size will never get more than O of h for a balanced tree. O of h where h is the height. So let me see. 121. I'm feeling good. We're gonna keep going here. Let me check out. Haven't looked at the analytics. Okay, you gotta keep track of the analytics on the stream. That's what you gotta do. All right. So minimum cost to move chips in the same position. We have n chips where the position of the ith chip is position I. We need to move all the chips to the same position in one step. We can change the position of the ith chip from position I to position I plus 2 or position I minus 2 with cost 0, or position I plus 1 or position I minus 1 with cost 1. Interesting. First step, move the chip at position 3 to position 1 with cost 0. So we want to get everything in the same spot. What? Wait. Position 2, 2, 2, and 3. Okay, there's one. I minus 1. Wait, is this 1 because I plus 1 or I minus 1? How is this? Oh, in position 1 there's 3, and in position 2 there's 3. In position 1 there's this many, and in position, okay. This one's gonna be good. How do we figure this one out? Minimum cost. Sounds like, I don't know, when I hear minimum, sometimes I think like dynamic programming or cost, something like this. Total cost is 2. We want to move all of them to the same position. I mean, the minimum cost is 2, and I can always move, like, can I move all the ones that are at 2s first? And where do we want them to even converge? Like, why would I make them want to converge here? Second step, move the chip from position 2 to position 1 with cost 1. Total cost is 1. Here we converge in the middle. But how do we know like where we want to converge to, right? That's the key question. And if I'm given a ton of these, how long is position? Dot length 100. Okay, classic time to draw here. It's gonna be a little bit annoying, but I kind of just wanna, is this, that's cool. It's not really gonna help, but okay, no. I was hoping that would help me a little bit. No, wait, I keep doing the same thing. I just want to make, is there not like a rectangle here? Oh, there you go. And I don't want that to be my stroke style. There you go, solid. Okay, we have something like this. Here, draw our line. Coming up with some arbitrary so how and why, if we have something like how can we, let me move this a little bit here. So we want a minimum cost to move chips to the same position, but we don't know what position. It's just a position that's going to afford us the minimum cost. If I move any of these chips plus or minus 1, it's going to equal 1, but if I move it 2, it's 0. It almost sounds to me like I always want to take advantage of the plus or minus 2, I think, because that's a cost of 0. So the most amount of times I can take advantage of that seems like it will be useful. Like if I started doing this greedy, like I say, okay, I can move this one where? I can move it to here, or I can move it to here. Okay. This one, I'm just kind of going greedy. Move it here, or move it there. This one, we can move it here, I guess. Can't move it there because it's out of bounds. And then this one's over here. We can move it there. And then finally, we can move all these 1 over. So wait, did we just, is that, well, can we just keep moving them by 2s until we get to like a spot where we're just gonna have to move it by 1s? Does that make any sense? What would happen if I do, oh yes. Look at that. I got the yes from Sam. We're on a good path here, fellows. We're on a good path here. That's sort of what I'm thinking of doing. Like I can move 1 there, so that's no cost. I can move 1 here. I can move 1 there. Oh, but see that actually, well, no, wait, I can move this one there. Wait, is that always 1, 2, and why is it like this? Because I move 1. Oh, wait, what? Oh, we gotta move 1. This has 4, and then we remove. Oh man, that makes it even trickier. I don't have to move the whole pile, right? I can just move 1. I'll move 1 there and then another 1 there because I've already exhausted my 2 options. I guess by the time I get to the final one, oh, I think maybe I'm onto something here. So let's say we move these 2 here, and then let's say we just, okay, like that's cool, whatever. And then we move these 2 here, okay, and then move these 2 here, that's cool, and then move these 2 here. Does that now just mean that I have to do like 4 of these onto there? Anything at all until you said it. No, I think it might be DP2. See, I sort of thought about DP first, but I'm not too experienced with that. But I'm wondering if I put, what would this look like? This would be, I just want to see like what it would be like if I did 0, right? 0, 0, 2, 2, 1, 1, 3, 1. Like what are we getting for the output here? Would it be 4? I'm just curious. Position, wait, what? Position must contain values. Oh, okay. They will each have. Oh, I see. They're only telling us where. Okay. We're only getting the positions where. Position 2. I see. So I'm not drawing this out right. No, I'm not drawing this out right. 0, 1, 2, 1, 2. Yeah, wait. 1, 2, 3, 4, 5. Why can't I copy? I don't know why it wasn't letting me move that there. I'm almost thinking like I just want to see. Okay, so position. There's how many in position 3? There's 2 in position 3. There's 2 in position 4. 1 and 5, 1 and 6, 3 and 8, 3 and 7, and 1 and 8. Okay, let's copy this guy. Okay, expected 4. So that's fine. That's good. Because we did that, right? That's exactly what we did for the greedy solution. So now let's try and figure this out with, I guess we can do DP or greedy. But if it was greedy, like, can I just go back and forth over and over? That sounds kind of like a waste of time. Well, let's see. Let's try greedy. I move this one to, excuse me. I'm moving from left to right. I come across this one. I move it 2 to the right if I can. Okay, cool. Then I come to this one. Maybe I move this one to the right if I can. Okay, cool. All right, I come to this one. I can't move it 2 to the right. So let me start from the back. This one I'll move 2 to the right. Okay, cool. This one I can move 2 to the right. All right, cool. And then I start from the left. Go over here. I can't move this one 2 to the right, but I can move it. I guess anytime I can't move it 2 to the right, can I just move it 2 to the left or 1 to the left? Let me actually do that. I want to amend this solution. Okay, so I can move it 2 to the right. I move it 2 to the right. Cool. I can move this 2 to the right. 2 to the right. I can move this one 2 to the right. 2 to the right. I can move this one 2 to the right. 2 to the right. Can I move this one 2 to the left? No. But can I move it 2, or can I move it 1 to the left? Yes. And I just move it 1 times however many are at this current position. I'm purposely scrolling up on the chat so I don't see your solution, Sam. Or like I don't want too many hints, but let's see. I can just move it 1 to the left. So now we have this big thing here. Now, do I then need some other, like, do I have to like go through this whole thing again? How long is this going to be? 100? When have I exhausted all? I know I've exhausted it when I have all the counts there. Or maybe I've exhausted it whenever I can check at any given point. Maybe after I move them, I can check and say like, are my, no. Can I say if my left and right are 0? That might not necessarily mean, yeah, that might not necessarily mean anything. It'd be nice if I knew ahead of time how many chips I have. But yeah, this is definitely a thing here. Now with DP, how do I even try to solve this? Wait a second though. Okay, so okay, like this one, like, will this just be, I'm at the end so I can't do anything here. If I'm at the right, if I have 2 to the right, can I bring those here? Because that would minimize my cost. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80, 81, 82, 83, 84, 85, 86, 87, 88, 89, 90, 91, 92, 93, 94, 95, 96, 97, 98, 99, 100, 105, 106, 107, 108, 109, 110, 111, 112, 113, 114, 115, 116, 117, 118, 119, or can I just always do, okay, it's like this is 1. Okay. This is now, no, yeah, see, this will be 4. That's already 5. That's way more. That's way more than what we want. Okay, so I feel like it's a greedy solution. It's just trying to figure out how to actually write that out. That's the confusing part. Get some more water. Only because I don't want to have to like go through this whole array multiple times to check and see, do I only have one position filled up? Let me see, because we're approaching. Let me see something. 109. Hoping we did at least 6. Ooh, okay, we did 7 questions. I mean, that's pretty nice. I think I might, okay, I think we know what we have to do here. It's a matter of figuring out the actual algorithm. You know what though? To make it up to you guys, there is one question I wanted to try out from yesterday. Sum of root to leaf binary numbers. I think I figured out how to do this one. And sorry for like context switching, but hear me out. 101. Okay, so let's draw this one. I'm gonna keep this around because we're gonna visit that tomorrow. Or maybe during a weekly roundup. I gotta see. 101. Okay, so 101. 0101. Is it 0101? Yeah, 0101. 0101. Okay. I think here 1 0 1 0 1 0 1. Okay, what we can do here, I think, right, is we can start building up a binary string at this point, right? Like we have 1. What can we do? Like we have 0 0 0. We can OR it. We can OR it with 1, and that becomes like, let's see. Or even better, no, we have 0 0 0. What do we do? Like in the beginning, we can take our current sum, go right by 1, and then we can take current sum or equals root.val. I think we can do this, right? So we can do 0 0 0 left shifted by 1, which it effectively stays at 0 0 0, and now we do current sum or equals root.val. So now this really becomes a 1, right? So if we copy this and go down here, what do we do now? We're like at another depth, right? So if we bit shift this by 1, we'll have 0 1 0, and then or root.val leaves it at 0 1 0, and then we get here, we shift it again 1 0 0, right? And then we get here, do the same thing. So anytime we're at a leaf node, we take the sum. So let's see if we can do this one, because I want to make it up to you guys here. So let's say we have, if I pass in sum here, sum equals 0, I want to check for leaf nodes here. So if root is equal to null, return 0. If not root, if root.left equals null and root.right equals null, we'll do something. Now let's think about this. Return. We can do return. Can I just actually take Yeah, no, let's come up with like const new sum. We can left shift it and okay. We can have like new, should I say like new mask? New mask sounds weird. Or we can say shifted sum is equal to sum here const new sum equals sum or equals to root.val. Here we can return sum of root to leaf of root.left and new sum plus sum of root to leaf of root.right and new sum here. Now, do I always want to do this if it's a leaf node? So it's not null. So I know I have at least a value. So maybe I actually want to do this here. I know root's not going to be null, so I can do something with it. And then maybe here I just return new sum. Would this work? Four and 22. I think I just messed something up here. Oh wait, no, this should be this, right? No, it should not. That's fine. Const of shifted sum. What are we gonna return? What are we gonna return for the other ones? Like here it's only getting 1, 0, 0. That's just a 4. Come up here. Go to the right one. Okay, come up here, go right. What do we return in the cases where, yeah. It's always hard for me to figure out what do I do in the intermediary ones here? I can also just keep track of sum as like a global, not the nicest thing. Do something like this. Let me just cut all this out. Turn root. Oh, traverse is over here. This is the end of that. So let me move all this. Traverse, do that. Put this here. If root is null, return 0. That's fine. I mean, I don't even need to. I can just say if not root, return shifted sum. All right, new sum, bam, root.left. Here we can just go sum or traverse root.left. And then here, traverse root.right. Let me put the AC on again. Traverse root.right. Let's just take this piece off here. So now if we have root.left here, we can just say sum plus or equals new sum. We can de-indent all this. We can say traverse root, return sum. Can remove this from here. See how this works now. Oh man, I feel like we're so close here. And just to make sure, right? Can I not dock this? Okay. If I'm going through here, if not root return, okay, shifted sum is sum. Oh, but I'm modifying this every single time. Okay, well, I know it's gonna be like this. Maybe we just need to, I think. Yeah, let's pass in the current sum. Current sum equals 0. Shifted sum is current sum, okay. And new sum is current sum, this. We can set this equal to current sum. Where's the exit? Okay. And here we'll say new sum. No, I think this should be new sum, right? This should be new sum. Sum plus equals new sum. So let's again open this up here. Let's see. So we're at 1. It's not. So shifted sum is current sum 0. Less than 1 still going to be 0. But now here we have, let's see, let shifted equals shifted 1. So it's 1. Take the new sum, and then we'll just keep adding the new sum like this. And then we still get 4 again. Is it because we're not? Shifted sum 1. Okay. Go to the left, or with 0. We go to the left, that's the new sum. Here we go to the right. I feel like I'm so close, but I'm probably just missing something very simple here. So we're like way over the hour. Typically this is like a weekly roundup length sort of thing here, but I've had a really great time doing this today. Thank you to everyone that joined. Hope to see more of you all tomorrow. I'm ecstatic for the amount of growth that this channel has seen, for the amount, I mean, I've had like people reach out to me telling me about how like this has been helpful for them. So I think that's so cool. I mean, we're at 127 subscribers. I want my first milestone to be like a 250, and then from there like double every after that, like get to 250 subs, get to 500, get to 1,000, 2,000, etc., etc. If we can even get that big. I think that a lot of people are trying to get into the software industry right now, and it's difficult for them. Even for me, I'm currently in the software industry, but I want to sharpen my skills, and I try to keep a pulse on the industry. So oftentimes it's hard to find the time to make a habit out of this and really get good at it. So I hope that others watching this can benefit from these streams. And like I said, I'm looking forward to seeing more of you all next time. Happy coding, and have a great rest of your Monday. Later, guys.